Good morning. I am Heidi Hittiarchi. My IT number is IT 22 32 32 and 48. So, hi everyone. In this video, I'll walk you through a text classification project where we train a convolutional neural network in 1D vector to automatically categorize these news articles from BBC into topics like business, sports, or tech. So, let's break down this code. First, we start by importing all the required Python libraries such as pandas and numerical Python for data handling, skip-learning, and for pre-processing and splitting the data. As well, I'm using TensorFlow Keras for building a neural network. Then we upload our CSV file here by uh, using Google Colapse file upload feature. Load it into a pandas data frame and quickly print out the first few rows to make sure the data set looks good, as you can see over here. In total, there are 2,225 entries in order to test out. So next, in order to understand the data, we then visualize the distribution of the article categories using a seaborn. This gives an idea of whether a dataset is balanced or if some categories have more samples than the others. As you can see here, the datasets are a bit imbalanced, but not too much. Next, we use label encoders to convert category names into numerical labels and then one-hot encode them for multi-class classification. For the text data, we use a Keras tokenizer to convert words into integer tokens, as you can see here, and pad all sequence to uniform a length of 200 words only, so the model can process them efficiently. This is how we prepare the data for the model, right? And next, in this code, what we do is we split the data into training and testing sets. As you can see here, the test size is 0.2, which means it's 20% for testing and the rest 80% is gone for the training. Then here comes the fun part, building my CNN model, right? So we start with an embedding layer to represent words as dense 100-dimensional vectors, as you can see here. And next, we use a 1D convolutional layer because this is a text classification and not image to capture important local patterns in the text like word combinations that often appear together. A global max pooling layer has been introduced to the most important features. Uh, we add dropout layers to prevent overfitting and dense layers to learn higher level relationships, ending with soft max output that predicts the category. Next, as you can see here, the outputs are given. Next, we compile the model with a categorical cross and entropy loss and the Adam optimizer. Then training for 7 epochs. While training, we monitor both accuracy and loss for the training and validation set and later visualize them using a matplot library to see how the model improves over time. So this epochs and batch size have been tweaked frequently in order to check how these paragraphs respond to these tweaked parameters, and this was the best fit curve that I could get into. As you can see later, we can see that the test accuracy here is 92.58% and the test loss is 0.24. Here's a graph for training versus validation accuracy. As you can see, for the validation accuracy, even though it's lower than a training accuracy, is somewhat good because it shows that it is learning by improving its text classification through unseen data. And this is the training versus validation loss. Next, in order to see easily whether if the model is working is that after training, we evaluate the model on our test data to see how well it performs. Then we test it with a few example news headlines like a government announcement or a celebrity wedding, and watch it correctly predict categories like politics or entertainment. So I specifically chose these texts where I've used Jeff Bezos, a tech entrepreneur, but at the same time it's about a wedding. So to see how well it classifies, which is correct, it is an entertainment. And lastly, to finish off, we calculate the precision, recall the F1 scores, and create a confusion matrix to deeply understand how the model performs on each class. We also generate a full classification report that summarizes the accuracy um, across all those 5 categories as shown here: the business, entertainment, tech, sports, and lastly, politics. And that's it. In just a few lines of code, we built a deep learning model that can read text and understand what's it about, all powered by convolutional neural networks, or also known as CNN. Thank you.